Welcome to CTOX Research Training Videos. Today we're going to be running a MARBIONIC Brevetoxin ELISA. This is an ELISA that we licensed from UNC Wilmington, and it has several components. The kit itself comes with 3 different reagents. Reagent A, which is brevetoxin bound to BSA, that's what sticks to your plate. Reagent C, which is your anti-brevetoxin antibody, which detects what's stuck to the plate. And reagent D, which is a secondary antibody. It binds to the primary antibody and is conjugated to HRP. And this is what allows you to detect binding of the brevetoxin standard or any brevetoxin that is in your samples. You'll have to provide several different reagents in addition to this kit that will to make the ELISA work. There is PBS and PBS tween. The tween is for washing the plate, and PBS, these are to dilute your samples. You'll have gelatins because you'll make a combination of PBS tween and gelatin to dilute some of your samples. You'll need a blocking buffer. We use and recommend Superblock from Thermo to block any unbound areas of the plate. And a high bind ELISA plate to run the assay in. In addition, you'll need to provide TMB and acid stop. This will allow the ELISA to be developed and then stop so that you can read it on the plate reader. Okay, so let's get started.
All right, so our first step here is to coat the plate with reagent A. That's the brevetoxin antigen conjugate that comes in the kit. It's going to compete for binding with the antibody with toxin in your sample. You're going to first dilute stock A from the kit, 1 to 300 into PBS that you provide. I've already done that here. It's in the 15 ml conical. I'm going to use a single channel pipette since I only need to test a small amount in this example. But if you run more wells, especially if you run an entire plate, you should use a multi-channel pipette to dispense your diluted reagents into the wells. Add 100 microliters of reagent A to each well and let it incubate for 1 hour for the antigen to stick to the plate. After incubation, dump out the leftover reagent A into the sink and tap the plate smartly on paper towels. Then you're going to wash with 250 microliters of PBS and dump it out again and tap it on the paper towels. Repeat for a total of 3 washes. Next, we're going to add 250 microliters of Superblock to each well and incubate for 30 minutes to block all the sticky areas of the plate that are not attached to the antigen conjugate. This is a really important step to prevent any non-specific antibody binding in the next step. So it's really critical that you block the plate. While you're waiting for the plate to block, you should make your PGT. First, you're going to need to dissolve 5 grams of gelatin powder into 100 ml of DI water and heat until it's completely clear. Then add 5 ml of the gelatin to 45 ml of PBS tween, which will cover a whole plate. Or if you need a smaller amount, you can use 1 ml of gelatin into 9 ml. That's what I'm doing here. You can save the stock gelatin in the fridge for later use, but you should make up the PGT fresh every time you run an assay. After 30 minutes of blocking your plate, dump out the extra Superblock and wash the plate 3 times again with PBS tween. Next, you're going to add the samples and standards to the plate. You're going to need to serially dilute the standard, and you can run the samples in the same way in dilution series or at one single concentration. It's up to you. In our plate setup, we put the highest concentration of standard in row A and then serial dilute down through rows B through H. To prepare, first you're going to add 100 microliters of PGT to the wells in rows B through H that you are going to then serially dilute. In this example, I'm showing you just the standard curve in columns 1 and 2. But if you wanted to test additional samples in serial dilution too, you would fill out additional columns in the plate with PGT. Next, add 200 microliters of 10 nanograms per mil standard to the wells in row A. You need to dilute the stock 1 microgram per mil standard that comes in the kit down to 10 nanograms per mil first, which I've already done here. After you add your standard and any samples you wish to serial dilute, you're going to use your multi-channel to dilute in the plate. You'll want to remove 100 microliters from row A, add it to row B, and mix. And you're going to repeat this down the plate. I usually mix 2 to 3 times in the well before moving on to the next row. Now your plate is set with all the standards and samples in serial dilution. If you don't want to dilute your samples, you can add them in the wells in a single dilution at this point. Next, you're going to dilute reagent C, which is the anti-brevetoxin antibody that comes in the kit, 1 to 300, and add 100 microliters of reagent C to each well with the standards or samples. Again, use a multi-channel rather than a single channel pipette if you have more than a column or two. I'm just using a single channel here for demonstration purposes. After you've added the antibody and your sample or standard, incubate for at least 1 hour. After an hour, dump out reagent C in the samples or standards and wash the plate 3 times with PBS Tween. After washing, we're going to add our secondary HRP conjugated antibody to all the wells. First dilute 1 to 300, which I've already done here, and then add 100 microliters of reagent D to each well. This antibody is going to bind to the primary anti-brevetoxin antibody, or reagent C, and allow for detection when HRP reacts with the substrate TMB. After an hour, dump out reagent D and wash the plate again 3 final times with PBS Tween. Finally, we're going to add 100 microliters of TMB to all the wells and wait for the color to develop. You're going to want to stop the reactions when the samples are within the color range of the standard curve. As you can see here, I have a nice blue color at the lowest concentration and not much color at the highest concentration, which is 10 nanograms per mil. So I can add 100 microliters of acid to stop my reactions. After that, read your plate on a plate reader at 450 nanometers and collect your data.